Good morning, everybody. This is the third lecture of Electronic Devices, Electronic 1 course. My name is Amr Abdul Bari. I am with Nearest University. Today we will extend the work of the diode to some applications, some special purpose diodes and its application because of its importance in the real world and in the other many application. You can see and you can find some diodes. Okay, so first there is the Zener diode. Zener diode is designed to operate only in the reverse breakdown. Not only, but we work and we use it in the breakdown region here, in this region. So there is, after some voltage in the reverse bias, you will see that there is a breakdown voltage, and then it is linear, like the an ohm, or like you have some internal resistance, and it's going linearly with the I reverse and V reverse, the voltage and the current. It is, as you see it, it is almost the same as in the forward bias. Okay, so this is the region that it's work. This is the symbol for the Zener diode. It's like this. This is a triangle, and we add these two, so we refer to the Zener diode instead of the normal diode. So this is make it useful in as a reference, voltage reference. Okay, so this is the primary application for Zener diode. Now let's see, as I said, there is some internal resistance. We call it impedance. We call it Zener impedance, ZZ. So this is the ratio of the voltage to the corresponding current. So the ratio of the voltage to the corresponding in the change in the current. This is the Zener diode. So if you have what is the Zener impedance? If you have the changes in the voltage from 4.79 to 4.94 and the corresponding change in the current, it is 5 millimeters. From 5 to 10, it's 5 millimeters. So you just take the difference between both of them and you calculate it. Very easy. Okay. Now the temperature coefficient, the Zener is affected by the temperature. So also we have a temperature coefficient. So we can calculate what is the change in the output according to the change in the temperature. So there is a change in the voltage, the output voltage, corresponding to the change in the temperature. So here we have two values. Here we have the change in the voltage to the change in the temperature. This is the TC, temperature coefficient. Or you can have the change in the voltage to the multiplied by the change in the temperature and divided by a reference, the VZ, the breakdown voltage. Okay, so maybe the positive or negative, it depends. So you have here, you have if it is above the 5.6 for some type of diodes, it is generally a positive temperature coefficient. It is less than 5.0, we name it as a negative. So we have an example here. This is the name. If you go to the store, electronic devices store, and you say I want one N756, this is the name of one of the devices, commercial one, and you take it, this is 8.2 at 25. This is the characteristics of this the Zener diode with positive coefficient at 5.4. So you want to calculate from these conditions that you know it, what is the output if we raise the temperature to 50. So you will take the difference in the temperature, you take it, the coefficient, you find the output voltage. He wants the output voltage, not the TC, because he gave it to you to see. Then this is not the output voltage, this is the difference in the voltage, difference from 8.2. so you take the summation with 8.2. this is the output voltage now. Okay, now in some applications, low current application, we can use it as a regulator for low current application, of course. So it can be used as a regulator in your computer or your laptop, for example, in the power supply. So here we have a input Vn, we have a resistance, we have the load. Then in the example here, he asked what is the smallest load that can be used here in this diode, Zener diode model or circuit. Then you will calculate with no load Zener current, this one Vn minus the Vz before no current, no load Zener current, there is no current before the 8 point, before the at the Vz exactly. So you calculate R, then you will have your load, you have your maximum load current, the RL 8.2 over 9.8 millimeter. This is the voltage here, and this is the voltage from this point to this point, so this is the same, and this is the current. This is the lowest current can come across at the 8.2. okay. Now let's see another application. So this lecture is about giving you some information about good applications in the diodes. So this is a 3-terminal regulators. The voltage regulator, it's giving you some output, whatever it is the input, so it is fixing the voltage at some level. So here the input come across some control unit, and it take feedback. If the feedback is some less or low or high, there is some error amplifier, and then return it back, and we take the reference from the Zener circuit. So it worked like we fix the voltage output, whatever the voltage input, and we calculate the error here. Okay, now the Zener diode, as it's a limiter, if you remember from last lecture, a limiter, we can limit the voltage that come across the output at some levels. Here he limit the voltage to the breakdown voltage plus the one diode drop, because both of them are in the other side. So you take the Vn in the positive plus Vz1 plus Vz2. okay, so it is 5.6, it's in the input. If the Zener diode is 5.6, so you take 5.6 plus 0.7, then it is 6.3, because one of them is working in the breakdown voltage, and the other one will work forward. So forward it is 0.7. okay, it will work in the forward bias as any diode. Now another diode, type of diode, this diode have a dielectric material inside here. So we have a dielectric material which doesn't connect any or conduct any current. So if we have P and N, they make as a plates here. It is like a changeable or a controlled capacitor. Okay, this is because the current will not come across, so it is like a capacitor for voltage here. So at the width of the depletion region, this is the depletion region here, increase with the reverse bias. Okay, so the question here, if the width of the depletion region increased, widen, so in the reverse bias. Does the capacitance increase or decrease? As you see here, he gives you some hints. The C, it's inversely proportional with the D, with the distance here. Okay, so it decrease. So the effect of the plate separation widen mean it is increased here in this wide, in this width. Then the capacitance will decrease. Okay. So this is a data sheet, and if you get the data sheet of some varactor diode, you will see that there is a capacitance tolerance range, and if you see here, you will see that it's giving you at some frequency, at some temperature. This is different type of varactors. This in reality. So the capacitance ratio, it's meaning the ratio of the diode capacitance at minimum reverse voltage to the maximum reverse voltage. This is another thing. You can see it in the data sheet. I encourage you, if you hear about some electronic devices, you should read, or you should have some information about the data sheet. You should learn what is the type, or what is the number of this. Any device, any electronic device have a number, small number, and if you search for this number, you will find the data sheet on the internet. Then you will see all the exact information, exact specification and standard for these devices. Now this is another circuit for tuning application. You can control the voltage that control the varactor. This is the varactor. This is two lines, and this different than the normal diode with one line, or the Zener diode, which have some lines here, small line here, small line here. Okay, so here, because of the change in the capacitance of the varactor, there is some change in the resonant frequency. So this is, we use it by varying R2. Where is R2? Here they change R2. So it's affecting the reverse bias, affecting the voltage come across the varactor. Then this will change the capacitance of the varactor and will change the resonant frequency. This is like tuning. If you, for example, choose in the radio, in the, I think in the old radios, the radio device, if you come across some radio channel and you want to change it, you make some there is a tuning circuit that you change the potentiometer here, then it change the frequency, the resonance frequency. Okay, but now everything is digital, so this is in the some analog radio. Optical diodes, one of the most known and well-known application of the diodes, it's the optical, the LED. All the LEDs around us, it is some diodes inside. So light emitting diodes, this is have very widely in size and brightness, and have very good applications from traffic signal, outdoor designs and general illumination. So very effective, have a specific lights, so it have a specific range of lights, all of them. So, and this is according to the specification in the data sheet. So here we speak about what is the peak wavelength of the green LED. It is 540 nanometer. You can get this in from the data sheet or from this figure. So here another thing is the optical characteristics is that it is have some it doesn't illuminate and give some lights in all the direction. It is not omnidirection, it is directional. It is directional in the light, so it have some concentration it concentrates the light in some directions. For example, from 10 degree to 10, from minus 10 degree to 10 degree, which is very good actually. So later we will have some here he gives you some certain voltage drop here. This is very easy for question. If you have the voltage Vs minus the V, where is V? A certain bright red drop 2.2 at maximum current 20 millimeter. What is the series resistor? Resistor is required to limit the current to 20 millimeter from 5 source. So you take the difference and multiply it by the I, you get the resistance. Very easy. Now there is some other application. This is the maximum power ratio. The power, you get the power by multiplying the voltage by the current. Now there is this is another type of optical diodes. This is photodiode, which is sensitive for the light. So at some voltage or some lights, it will go up the current in the reverse bias. So, and there is some place we call it the dark current, because it's before there's a small that doesn't expose to light, there is some dark current. It's a tiny current. Now there is one of the most important application or specific purpose diodes is the laser diode. Laser diode means that I have a diode that convert the electrical signal into a monochromatic light, into a laser light. It is produce an intense and narrow beam, more narrowing than the other one, the LED. Okay, so it's some combination here of electronics and hole in the depletion region. So this is the first question for you today. I want you to go to the book on the internet and read about how it is working inside, how it is working to finally get your high intense beam. Okay, and what's happening for the electrons. Okay, so this is what's happening. You should read more and write something about that. So the most common is the laser are the most common of form of the laser made, the laser diodes. We use it in CD, laser pointer instrument, and range fingers. Schottky diode is one another special purpose metal to semiconductor. Instead of having P-N junction, we have N region and metal region. Okay, so it have a low forward voltage drop and a high efficiency, but rather low reverse voltage rating. Okay, so another one is BIN diode. B intrinsic region here, BN region here. So it in microwave application act as a voltage controlled resistor. So a resistance that is controlled by the voltage. It's certain type are used as a photo detectors in fiber optic. So there is many types of the special purpose of the diodes according to the characteristic curve of these diodes. For example, here tunnel diode have a strange characteristic curve, which here from B to C it is have a negative resistance region. Okay, but it's used in an oscillator circuit at microwave frequency, so we can make use of the negative resistance here. Okay, now there is a current regulator diode with a special purpose. So it have some whatever the voltage that you applied, it is have the same current. So whatever the voltage between 2 points here, it has the same current here, as you see, but return back to the other regions. Okay, So this is the common diode symbols. This is the Zener, as you see it. This is the light emitting diode. It's emitting. And this is the photo. It's receiving diodes. This is the laser, again the same as this is the LED. Shakti diode difference. So we use these symbols in the circuit simulator software and electronic, as you draw the electronic devices in the circuit simulator, or the before you implement your circuit. You will use, if you use one of them, you should use the diode symbol, the corresponding to the device that you mean. Okay, this is the varactor, as I said, and this is the other tree that I mentioned. Okay, so today I speak about the Zener diode, which is a diode designed for limiting the voltage across its terminal in the reverse bias, of course. The varactor, which is a variable capacitance diode. It is a capacitance that you can change its the capacitance using the voltage. Light emitting diode, LED, which is emit light according to if there is a forward current, and it have a specific beam, directional beam instead of omnidirectional. Electroluminance, the process of realizing light energy by recombining electrons in the semiconductor. Maybe this is related to the question that I asked. Okay, pixel in a LED display screen, the basic unit for producing color light consisting of red, green, and blue. Okay, photodiode, it's a diode that which in the reverse current vary directly with the amount of light that come to this diode, so it's receiving. The laser, what is the laser? It's a light, this is I think the abbreviation, light amplification by stimulated emission of radiation. So this is the laser. This also related to your question. So this is what I speak about today is some special purpose. We don't concern about the details. I want you to know each one of them, how it works, what is the purpose, what is the application. So when you later want to use something or some device, you have some information, basic information. Other information you can find it in the data sheet. In the data sheet about each device, you can find a lot of information about that. Okay, that's it for today. Thank you for listening.